Hello, mathematics students. Today we're going to be going over the polynomial identities course activity. This is going to be from Unit 2 of Algebra 2, but I think it's also in the integrated math. Let's go ahead, and when you're on the activity, we're going to go ahead and skip to page 4. This is where the first problem is. And basically, hopefully you kind of already know this one, but if not, no big deal. I'm going to go over it, but try to see if you can answer some of these on your own. Basically, we want to take each of these and we want to multiply some of these out. Some of these we want to factor. For this first one, I'm actually going to do this one first. So we're going to do 2x plus 1 to the power of 3. Now, hopefully you know that to the power of 3 means that thing is multiplied by itself 3 times. So it's essentially 2x plus 1 times 2x plus 1 times 2x plus 1. So this is 2x plus 1 to the power of 3. So I'm just going to write it 3 times like this. Okay. And I'm actually just going to multiply these first two together, and you kind of just FOIL here. So 2x times 2x is 4x squared. 2x times 1 is plus 2x. 1 times 2x is another plus 2x. And then 1 times 1 is 1. I can go ahead and combine this 2x and this 2x, giving us 4x squared plus 4x plus 1. The 2x plus 2x gives you the 4x here. Now we also have to multiply by another 2x plus 1 here. So this power to the 3 ends up, we have to multiply this another binomial here. Now what happens here is that each term in this first trinomial multiplies with each term in this binomial. Okay, so 4x squared is going to multiply with each of them. Then 4x is going to multiply by each of them, and then 1 is going to multiply by each of them, and then combine like terms once again. So 4x squared times 2x is 8x to the third, because x times x makes x to the third. Then 4x squared times 1 is 4x squared. Then we're going to multiply the 4x times each of these. So 4x times 2x is 8x squared. 4x times 1 is 4x. Then we multiply the 1 times each of these. So plus 2x plus 1. Combine like terms here to find our answer. So we can, this 8x to the third doesn't combine with anything. So I'm just going to go ahead and write it. Then I'm going to combine my x squared. So I've got a 4x squared plus an 8x squared, giving us 12x squared. We also have a 4x plus a 2x, which gives us plus 6x. And then we have a constant plus 1. Okay, so 8x to the third plus 12x squared plus 6x plus 1. Here we go. So that goes right here. Okay. You may have noticed that some of these tiles that we're going to move here require multiplication. So one thing I could do is I can go ahead and grab this thing and multiply it out, and that should be one of these answers down here. So let's again multiply this out. X times x, then x times -4. X times x is x squared. X times -4 is minus 4x. Then we multiply this 4 times both these terms. 4 times x is plus 4x. And 4 times -4 is -16. So here you may notice that the -4x and the positive 4x cancel, giving us x squared minus 16. Okay. Now you can probably already guess which of these go where, because this 2x plus 1 to the power of 3, that would create, much like how we did this one, to the power of, oops, I put this in the wrong spot, didn't I? This goes here. See how this 2x plus 3y squared? Well, when you multiply that out, you're going to get something with the terms all spread out, right? Similarly, when you multiply this thing out, you'll get here. Notice that This one's kind of weird, this last one, because when you multiply these two polynomials together, you actually get something smaller, right? Well, we're going to actually go over that in more detail in some of this assignment. So keep this last one in mind, that when you have something to the power of 3, and then this is kind of something else to the power of 3 in a way. This is 2y to the power of 3. You could actually factor it into something longer like this, a binomial times a trinomial, right? So we're actually going to get more detail into that, but don't worry about it too much for now. Let's go ahead and move ahead. And in this section, there's a couple of identities you really need to know. So the first one, and if you need to, you should write these down on a separate piece of paper. So the first one you need to know is this difference of squares. That's one you probably already should know because it was covered in Algebra 1. But if you don't remember it, that's fine. Just go ahead and write that down. And we actually saw an example of this in the last problem. Remember the x squared minus 16? That factored as x plus 4, x minus 4, right? So this is something we've seen before. Write that down. We're going to need that later. The other one we're going to need is actually this sum of cubes. So when you have something to the power of 3 plus another something to the power of 3, this is like what I was saying with the last tile on that previous problem. It factors as a binomial times a trinomial, and this gives you the pattern of it. Okay, we're going to go into deeper in this pattern, but if you can, write that to the side. We're going to need that for later. I'm going to go ahead and grab it here with my snipping tool. Okay, now let's go ahead and move on. We're going to move ahead to this page here. So this is actually, we're going to use that difference of squares. When you have a squared minus b squared, how does that factor? Well, you may say, well, this is not a squared minus b squared. This is a to the 4th minus b to the 4th. Well, technically, yes, that's true, but that's also something squared, right? A to the 4th is a squared squared. Okay, so let me show you what I mean. So I'm going to grab this, and how can we factor this? Well, I could write this as a squared minus b squared squared. Okay, this is not that important, but I want you to see that these are both perfect squares. Okay, what you would do when you want to factor this thing is actually pretty interesting. You want to take the square root of this first term. So the square root of this is actually a squared. So that's a squared. And you do minus, you could put the plus first or the minus first. It doesn't really matter. Usually I guess, well, it doesn't matter. And then the square root of this one is b squared. Okay. Then we do one with a plus. So a squared plus b squared. Now you could always double check. If you multiply this back out, you should get back to where you started. So that's one way you could always check to make sure you're doing it correctly. Now you may notice that this difference of two squares, oh, this reappears, doesn't it? We have a perfect square minus another perfect square right here in this factor. So we could also factor that down even farther. A minus b, again, taking the square root of each of these. A minus b times a plus b. Now, can I do that with this factor as well, the a squared plus b squared? Well, no. In order to follow that pattern, it has to be a minus. So that's why we can do the factor it this way for the starting one, but also for this factor as well. But we cannot for this factor. So that just stays as is. A squared plus b squared. And again, if this was a minus, you could factor it further. All right, so here we go. Okay, hopefully that made sense. Let's move along. Okay, so here we want to factor this thing, and that's where that one thing I showed you comes up again. And actually, it's on this page as well. So I'm going to actually grab this perfect square trinomial formula here, and hopefully you have it written down as well. But basically, That's actually not the one I want. Let's go back a couple pages. I want, yes, this one. Okay, so we're going to use this guy here. Hopefully you wrote that down. And if not, you have another chance. All right, now let's move ahead to page number 9. And I want to factor this using this identity, okay? So essentially when you have something that's a perfect cube, so that means to the power of 3, plus another thing that's a perfect cube, so that means something to the power of 3, then you can factor it in this way. So here in our example, we have 8x to the 6th plus 27y to the 3rd. Okay, now in this case, these are both perfect cubes because I could rewrite this one as 2x squared to the power of 3, right? Notice in my formula, I need it to say to the power of 3, right? Power of 3. So in this case, my a is 2x squared. And then we have a plus. And then what would be the cube root of this? Well, this would be 3y to the power of 3. Notice 3y to the power of 3, that would be 3y times 3y times 3y. Well, that would give you 27y to the 3rd. So that's why we can rewrite it in this way. So our a in our formula is going to be 2x squared, and our b is going to be 3y. So everywhere we see an a here, we're going to replace with 2x squared. And everywhere we see a b, we're going to replace it with 3y. So this is essentially our a, and this is essentially our b. Okay, so now how does this look? Well, I got our first parentheses, a smaller parentheses, a plus b, right? So our a, 2x squared, plus b. What's our b? 3y. I hope you're writing down everything I write. If you write down everything I write and everything I tell you to write, I guarantee it'll make a lot more sense. You'll understand it way better. You'll do better on the test, everything. Okay, so write down everything I tell you to write and write down everything I do. Okay, then we have a squared. So what's our a again? Well, it's 2x squared. And we want to square that. So we want to do, when it says a squared, we want to do 2x squared, right? So that means times itself. So this a squared, where it says a squared right here, we're going to do this a times itself. So that's going to make 4x to the 4th. So that's what we're right here, 4x to the 4th. Then we have a minus, and here it says a times b. So we're going to do a times b. Well, what's that going to be? Well, our a is 2x squared, and then times the b, which is 3y, right? Our b is 3y. So that's going to make 6x squared y. 6x squared y. Notice in our formula next, we have a plus, and it says b squared. So we're going to do plus. Now we want to do b squared. So what's b squared? Well, that's 3y squared, right? So 3y times 3y. That makes 9y squared. And there you go. So when you want to put in your answer, make sure to use this equation editor. You can make your answer look very nice. So what is it again? 2x squared plus 3y, 2x. So when I want to do squared, I'm going to use this little tool right here. Notice it now puts my cursor there, right? 2x squared plus 3y, close parentheses, open parentheses, and go ahead and finish typing the rest in. I can count on you to do that. Okay, let's go ahead and move along. Once you're done with that, let's move along, move along, move along. Okay, now if you look on page 11, there's this horrible looking formula. It's right here, right at the top. a plus b to the power of n. This is like the binomial theorem formula here, and it is really bad looking. I want you to ignore this, okay? Don't try to memorize this. Don't try to figure out what it's talking about for now. What I want you to really do is just ignore it, okay? We're gonna move along. I'm gonna show you a better way to do this, okay? So you don't have to look at this process. What I want you to do for the most part is ignore it. But I do want to point out one thing, and this is going to come into play. Notice if I'm doing x plus y to the power of 5, I want you to notice what happens to the powers of x and y here. I'm looking on page 12, by the way. Notice it's x to the power of 5, y to the power of 0. And then the next term has x to the power of 4, y to the power of 1. The next term has x to the power of 3, y to the power of 2. Notice my x degree is decreasing each term, right? X to the power of 5, x to the power of 4, x to the power of 3, x to the power of 2, then 1, then 0. But our y's are increasing. Y to the power of 0, y to the power of 1, power of 2, y to the power of 3, power of 4, power of 5. Okay? Now, that's how all these are going to be done when you have x to the power of 5. If this was x to the power of 6, if this was x plus y to the power of 6, then your first term would have x to the power of 6. Okay, so whatever the highest, whatever the degree that you're multiplying whatever degree of the binomial, you have x to the power of whatever that binomial is, and then it decreases. What I want you to notice too is that if you look at the degree of the x and y, those add to 5, right? 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4, 0 plus 5, right? They all add to 5. So when you add these powers, they always add to the degree that you have your binomial to. So since we have our binomial to the power of 5, these will add up to 5. If this were your binomial to the power of 8, then these would add to 8. Okay, all the way down. Okay, I know it was a bit long-winded, but it'll make sense as we go through. Okay. Once again, let's ignore this. Meet me on page 15. All right. Here's where we're actually going to. I'm going to show you. We're actually going to skip this page because there's something else I want you to learn first. Okay, and that's this triangle right here. So if we look on page 16, we'll notice this triangle. It's called Pascal's triangle. I'm going to show you how to create it. Okay, so Pascal's triangle, and again, you should write this down. Notice you put a 1 here. So that's your first step. Okay, now you need to learn how to make Pascal's triangle here. So your first step is to put a 1. Simple. Then below that, you're going to put a 1 and a 1. Then below that, it's always 1s on the sides. Okay, always 1s down the side. But what about this middle term here? Okay, so this middle term is actually going to be, you add together this plus this, that gives you the middle term. Okay. So your next layer on Pascal's triangle will have a 1. Then 1 plus 2 gives you 3. Then 3 plus 1 gives you, 2 plus 1 gives you 3. And then you put a 1 at the end. Then the next layer, you put a 1. Then 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. And then a 1. You put a 1. The next layer, 1 plus 4 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10. 4 plus 1 gives you 5. And then 1 at the end. So this is how you form this triangle, okay? It's very important that you know how to create this thing. This is known as Pascal's triangle, and it's going to help us out a lot. So this gives us a direct pattern in the binomial theorem, okay? So this triangle is what it allows us to not have to memorize that binomial theorem, okay? Because we have this triangle, Pascal's triangle, okay? So knowing how to create the next layer down is important, and you're going to see why, okay? So Okay. And how do you use it? Well, you would use this top layer, or this 1 layer would be for x plus y to the power of 1. You use this layer for x plus y, or a plus b, whatever, to the power of 2. You would use this layer for x plus y, I think you already know what I'm going to say, to the power of 3. You would use this layer for the power of 4. You would use this layer for the power of 5, power of 6, and this layer for the power of 7. If I need to the power of 8, then I just make another layer. Okay, so you can always just make this thing taller just by creating another bottom layer. Okay, and as you can see, the layers get bigger as you go down. Okay, we're actually going to be able, I want you to make this triangle all the way down to the 10th layer. Okay, you're going to have to make this triangle all the way down to the 10th layer. Okay, so how do we use this triangle? I'll show you. So let's go ahead and go to this problem right here. We're actually on page 19. Okay, we skipped some problems earlier, but we'll get back to them. Now I want you to start on this page right here, page 19. To expand the binomial expression 2x to the third plus 3y squared to the power of 7, using the binomial theorem, what should be substituted for the values? So in this case, our a is going to be 2x to the power of 3. And our b will be 3y squared. Okay. Now, using Pascal's triangle, which layer or which row of Pascal's triangle will be used for 2x to the third plus 3y squared to the power of 7? Well, you would use this row right here. It's this, you can count the top, this 1, just at the very, very top, this 1 as to the power of 0. So 0, 1, 2, 3, 4, 5, 6, 7. I'm using the 7th row down if I'm counting the top, the very top as 0. So I'm using the 7th row down because it has to the power of 7 there. You see that? So this 2x to the third plus 3y squared to the power of 7, that tells me I'm going to use that 7th row of Pascal's triangle. Now, how am I going to use it? All right, well, how do we use this triangle? So I'm going to show you. Let me go ahead and grab this triangle. I'm actually just going to grab this row here. Okay, so this is the row we're going to use. And I'm going to write down my binomial. It is 2x to the third plus 3y squared to the power of 7. Okay. So now think of this as your A and this as your B. Okay. So what you would do is first you write these numbers here as these will be your coefficients, your starting coefficients, and you'll see what I mean. I like to write these numbers with quite a bit of space in between because we're going to have to write some stuff in. So 1, then a 7, then a 21. Notice I'm leaving quite a bit of space here between these numbers. Then 35, then 35 again, then 21, then 7, and then 1. A little bit short on space here. 7, and then 1. Maybe I'll just make this bigger. Okay. So then let's go back to the front here. Okay, so we have this 1 right in front. And then what you're going to do is you're going to put your A. You're going to put your A to the power of 7. Okay. Plus, here you're going to do your A to the power of 7, B to, oh, I messed up. A to the power of 6, B to the power of 1. Notice these powers, 6 plus 1, that adds to 7, right? So that's important. Then this will be 21 a to the 5th, b to the power of 2. Notice that, again, they add up to 7, and my degree for a went from 7 to 6 to 5. See how the power of a is decreasing as we go, right? Then a to the power of 4, b to the power of 3, the b powers are increasing. A to the power of 3, b to the power of 4, 21, a to the power of 2, b to the power of 5. Again, they add up to 7. A to the power of 1, b to the power of 6. Then lastly, b to the power of 7. Essentially a plus between each of these. Okay. Now, what's our a in this case? Our a is 2x to the power of 3. So this is going to be 1 times 2x to the power of 3 to the power of 7. Right? Because my a is 2x to the power of 3. So this says a to the power of 7. So that's 2x to the power of 3 to the power of 7. Plus 7. And then we have a to the 6th. So that's 2x to the 3rd to the power of 6 times b. b is 3y squared. Okay. So in other words, this thing becomes this thing when I replace a and b with a and b from here. Hopefully that sort of makes sense. Now we're going to continue down the line just like that. So this next one will be 21, a to the 5th. So that's 2x to the 3rd to the 5th. Then b squared. So b is 3y squared. And we have that squared. Okay, I know this takes a while, but I want you to be patient, write this down, and just continue along. 2x to the 3rd to the 4th. b is 3y squared to the 3rd. Kind of getting off base here, but this one is this one. Okay. Then plus 35 a to the 3rd, so 2x to the 3rd to the 3rd, b to the 4th, so 2y squared to the 4th, plus 21 a squared, 2x to the 3rd squared, 3y squared to the 5th, plus, oh no, I'm running out of space, 7, 2x to the 3rd times 3y squared to the 6th. I'm running out of space. Plus 1 b to the 7th. So 3y squared to the 7th. Okay, I know that was a lot, but believe me, it would have been much worse without Pascal's triangle. Okay, so let's go ahead and let's look at our terms here. So what about this first term? So let me switch to a blue pen here. What about this first term? How can we rewrite it? Well, hopefully you have your calculator, okay? Because you would have 2 to the power of 7. Using my calculator, I can see 2 to the power of 7, which means 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. Multiplied by 1 doesn't do anything. And then we have x. What will be our exponent here? Well, when we have a power to a power, you multiply those. So this will be x to the power of 21. The next one, we're going to do 2 to the power of 6 times 3 times 7. 2 to the power of 6 is 64. Times 3 times 7 gives us, and again, times 3 because of this 3, and times 7 because of this 7. That gives us 1344. And then we're going to have x to the power of 18. 3 times 6, that's 18. And we have a y squared. That's 1344 there. Plus the next term, 2 to the power of 5, 2 to the power of 5. And then times 3 squared, that's 3 times 3. So that's times 3 times 3. And then we also have a times 21 here. That's in the front. So that's 6048. Then we're going to have x to the power of 3 times 5 is 15. And then we have y to the power of 2 times 2, which is 4. Okay. I hope you're following along, but basically that this one gives us this one, right? Okay. Let's move along. Plus, here we have 2 to the power of 4 times 3 to the power of 3. 2 to the power of 4 is 16 times 3 to the power of 3 is 27 times the 35 that's in front. So that's 15,120. Then we have x to the power of 12 because 3 times 4 is 12. And then power to a power, you multiply those. So that's y to the power of 6. Again, this one is the one we just did. Okay. Plus 2 to the power of 3, that's 8 times, wait a second, I messed up. This should be a 3 right here. Okay, 3 to the power of 4, that's 81. 8 times 81 times the 35 that's in front. So that gives us 22680 x to the power of 9, y to the power of 8. All right. Once again, there was this one that gave us this one. Okay. Plus, I'm going to do the 3 to the power of 5 first. So 3 to the power of 5 times 2 to the power of 2 is 4 times 21 gives us 20412 x to the power of 3 times 2, that's 6. Power to a power, you multiply those. So y to the power of 10. Plus, second to last term, 3 to the power of 6. 3 to the power of 6 is 729 times 2 times 7 gives us 10206. We have x to the power of 3, y to the power of 12, and our last term, 3 to the power of 7, which is 2187. And we're going to have 7, and then we're going to have y to the power of 14. Again, a power to a power, you multiply those powers. So this whole thing that we just got would be if you did 2x to the power of 3 plus 3y squared to the power of 7. Now, this is much, I know that took a while, but this is much, much, much faster than you would have had to do traditional way. The traditional way, we would have to do 2x to the power of 3 plus 3y squared times itself 7 times. Okay, so think about all that multiplying and combining like terms and all that. Don't have to do any of that. We got this all the way down. Okay, so using that, I want you to put the correct answers in here, right? So which one had x to the power of 9, y to the power of 8? Our x to the power of 9, y to the power of 8. Oh, that's this one in red. So that's 22680 is the coefficient right here. Okay, what about this 2412? That's right here. Should have x to the power of 6, y to the power of 10. There you go. Fill in the rest here. Okay. So go ahead and fill in that the rest. These should be your last 2 terms here. Okay. Your last 2 terms go here. Okay. Again, just move these, whichever ones are correct, put them in here. Okay. I hope that made sense, because if it did make sense, then you're on the right track to finishing the rest of this. So actually, we're going to go backwards. We're going to go back to the ones we skipped. So that's on page 15. Now it's going to make our lives here a lot easier. Okay, so let's look at x plus y to the power of 4. So once again, we should look at our Pascal's triangle. Hopefully you got all this, because I'm about to delete it. So we're going to go ahead and grab this thing here, and we're going to use our Pascal's triangle to help us out. So that was 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, and this is the row we're going to use. All right, pretty simple. Now, that means it's going to be 1, 4. I'm leaving some space here, right? 1, 4, 6, 4, 1. And this is essentially our A and our B. So we're going to have A to the 4th here, plus, remember, these powers decrease. So A to the 3rd, then B, plus, then A squared, B squared, plus 4, A, B to the 3rd, plus 1, B to the 4th. And you are done. Wasn't that great? Okay. Now, instead of A and B, we'd be using X and Y. So this will be X to the 4th plus 4, X to the 3rd, Y, plus 6X squared, Y squared, plus 4X, Y to the 3rd, plus Y to the 4th. Okay. And you're done. So that's one. It's this one. Pretty sure. Yeah. 1, 4, 6, 4, 1 are the coefficients there. Cool. Now that allows us to do this, these extra long ones, this x plus y to the 10th. Now, x plus y to the 10th means we're going to have to make a much bigger triangle. So I'm going to go ahead and grab this, and we're going to make a huge Pascal's triangle. Okay. Again, starting with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. We're going to have to go all the way down to the 10th row. 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1, 1, 8. What's 21 plus 7? 28, 56, 70, 56 again, 28 again, 8, and 1. 2 more rows. 1, 9, 8 plus 28, 36, 28 plus 56, 84, 56 plus 70, 126, then 126 again, 56 plus 28 again, so that's 84 again, 28 plus 8, 36, 9, 1. Last row, 1, 10, 9 plus 36 is 45, 36 plus 84 is 120, 84 plus 126 is 210. 126 plus 126 is 252. 126 plus 84 again, 210, 120, 45, 10, and 1. So this is the row we're going to use. And we're going to have 1 x to the 10th. plus 10 x to the 9th y plus 45 x to the 8th y squared. Notice these powers for the x and y, they add up to 10. That's because this is a 10 right here. Okay. Plus 120 x to the 7th. Again, our x powers are decreasing, 10, 9, 8, 7. And our y powers are increasing. No y's, 0 y's. 1, 2, 3. Again, these powers add up to 10. All the way down the line, these powers should add up to 10. 210 x to the 6th, y to the 4th, plus 252 x to the 5th, y to the 5th, plus 210 x to the 4th, y to the 6th, plus 120 x to the 3rd, y to the 7th, and just continue. I'm running out of paper here, but hopefully you're not. 45 plus 45, x squared, y to the 8th, plus 10, x, y to the 9th, plus y to the 10th. 1, y to the 10th. The 1's not necessary. You don't need the 1 here either. Okay. So what is the 8th term in this expansion? The 8th term. Well, let's see. Counting my terms. 1, 2, 3, 4, 5, 6, 7, 8. So my 8th term is this. 120, x to the 3rd, y to the 7th. There you go. See if you can find the number term is this. Is 3rd, 4th, 2nd, or 5th term here? What number term is this? What number term is this? Okay, based on this expansion we made earlier. Okay, remember this was the 8th term. So, all righty. Hope that made sense. Okay, now if you hated Pascal's triangle, just know that would have been much, much worse with any other method. Okay, now I hope you know this formula here, the Pythagorean theorem. If you haven't seen this before, I'd be very surprised. A squared plus b squared equals c squared. Okay, we're going to learn some more patterns about this particular theorem. But ideally, you know this theorem already. I hope you do. Okay, so we're going to move along. And then when we get to page 23, we're going to stop right there. Okay, so which triples are Pythagorean triples? So a Pythagorean triple is a set of 3 numbers where the Pythagorean theorem actually works. Okay, now remember, a couple things for it to be a Pythagorean theorem. For one, they all have to be integer numbers. In other words, whole numbers. So this one's actually doesn't count because it has square root of 3. So if it has a square root of something, unless it's a perfect square root, like square root of 3 is not a perfect square root. So this one doesn't count as a Pythagorean triple because it has that square root of something. So you have to have all whole numbers for Pythagorean triples. Let's go ahead and check this set of first set of 3 numbers here, 8, 15, 17. So you would do 8 squared plus 15 squared. And I want to see, does this equal 17 squared? Okay. Now 8 squared, that's 64, because 8 times 8, that's what that is. 15 squared, I believe that's like 225 or something. Yeah. Plus 225. And I want to see, does this equal 17 squared? Which 17 squared is 289. Okay. Do these add up to 289? 64 plus 225. Yeah, it does. So it's both sides equal 289. So is this a Pythagorean triple? We would say, yes, it is. So we're going to go ahead and click that one. That's a yes. All right. Then check the next one down. Okay, so let me check the next one down. 9, 12, and 16. So I would check 9 squared plus 12 squared. And I want to see, does this equal 16 squared? Well, 9 squared, that's 81. 12 squared, that's 12 times 12. That's 144. And 16, I don't know if these are equal, so I'll put a little question mark here. 16 squared, I think that's 256. Yeah. Let's see, does this add up? Do these add up to 256? 81 plus 144. No, these add up to 225. So this does not equal 256. So we would not check that one. So do not check this one here, the 9, 12, 16, don't check that one because it's not equal. Okay, then check the rest of these. So you're gonna, well, don't check them. See if each of these are Pythagorean triple. All right, so use the Pythagorean theorem, see if the Pythagorean theorem works. If it does work, then you want to click that one. If it doesn't work, then don't. Okay, check the rest of these. Okay, once you're done with that, let's move along. Okay, we're almost done. Relating a polynomial identity to Pythagorean triples. In this activity, you'll relate polynomial identities to Pythagorean triples. Answer the following questions based on this triangle with side lengths x squared minus 1, 2x, and then x squared plus 1. And you can see here, the longest side, the hypotenuse, is the x squared plus 1. So that's your hypotenuse here. You always know it's the hypotenuse because it's opposite from the 90. The 90 always points, or the right angle always points to the hypotenuse. Okay, they're opposites. All right. Prove that when x is greater than 1, a triangle with side lengths x squared minus 1, 2x, and then x squared plus 1 is a right triangle using the Pythagorean theorem. So essentially, we're using the Pythagorean theorem here. So again, the Pythagorean theorem, a squared plus b squared equals c squared. So we're going to have, here I would use this, use the equation editor here, okay? So again, my factors were x squared minus 1, and then we're going to do squared on that. Okay, so that's our a squared plus b squared. Our b was 2x. So we're going to do 2x squared, and we want to see that it equals x plus 1 squared. All right. So I suggest showing all your work in this equation editor for full credit. But for me, I'm just going to go ahead and grab it, and I'm going to write it out. It might be best for you to write it out on a separate sheet of paper and then put your answer into the equation editor, showing each step along the way. Okay, so first I want to do this x squared minus 1 squared. So x squared minus 1 squared is x squared minus 1 times x squared minus 1. So I'm doing this part first. You just FOIL this out, multiply it out. So x squared times x squared, that's x to the 4th. X squared times minus 1 is minus x squared. Negative 1 times x squared is negative x squared again. Negative 1 times negative 1 is positive 1. We can combine these negative x squareds together. So that's going to give us x to the 4th minus 2x squared plus 1. Once again, I hope you're writing all this down. Now let's do our 2x squared. So 2x squared is 2x times 2x. That's the easy one. That's 4x squared. So I'm going to go ahead and put plus 4x squared equals, and I'm going to do this last one again in black pen. Okay, so x plus 1 squared, that's x plus 1 times x plus 1. By the way, if you're finding this helpful, if you're finding this useful, and you'd like to say thank you, all you have to do is hit that subscribe button, and that helps me out a lot. It costs you nothing, and it means the world to me. If you really, really want to say thank you, then you'd share this, share my content with someone who you think would find it useful. Okay, so on the right side of the equation, we have x squared plus 2x plus 1. Okay, are these equal? Well, yes, they are, because notice on this left side, I can combine this 4x squared and this negative 2x squared. So that gives me x to the 4th. I can combine those, that's a positive 2x squared, and we still have a plus 1 here. Notice that equals this side, doesn't it? So since both sides are equal, that shows that the Pythagorean theorem holds for this relationship, okay? So you'd show that work here, showing your steps each along the way in this equation editor. I'm not gonna show all the full steps, but I'm confident you can do that, okay? Showing these steps in that equation editor. All right. And don't hit that X, by the way. When you're done doing that, click the done or okay down. Oop. Didn't mean to hit that. Make sure to click this okay. So whatever you put in here, make sure you put okay, and it'll show up here nice and neat. Okay. All right. Which identity is the result using the Pythagorean theorem? So we already showed the Pythagorean theorem holds true, which is a squared plus b squared equals c squared. Easy enough. Now, we can go and use this to help us find more Pythagorean triples. So we can use this x value of 3, and we're actually going to plug it into these things, but we're going to replace x with 3. So they're asking us to replace x with 3. So everywhere you see an x, I'm going to replace it with 3 to find our 3 side lengths for a new Pythagorean triple. So 3 squared minus 1. That's the first one. That's this one, right? 3 squared is 9. 9 minus 1 is 8. Now 2x. That's going to be 2 times x. X is 3. That gives us 6. And the third side length, the hypotenuse, that's going to be, I'll do it in black pen here. That would be 3 squared plus 1, which is 9, plus 1, which is 10. So this gives us a Pythagorean triple, 8, 6, 10. So we'd write right here, 8, 6, 10. And there you go. Oh, here they want it in order from least to greatest. So I'll put the 6 first. 6, 8, 10, like that. Okay, great. I want you to do the same for the 5 here. So again, replace the x with 5 for each of them, and you'll find another Pythagorean triple. Now, what about for this group here? That gives us the 8, 15, 17. And I want to use these things to help us. So 8, 15, 17. Okay. Well, I imagine the 8 probably comes from this 2x here. Okay. So that means my x is 4. And we could double check here because 2 times 4 gives us the 8. And then 4 squared minus 1, that's 16 minus 1. That's where we get the 15. And then x squared, so that's 4 squared plus 1 gives us the 17, right? 4 squared is 16 plus 1 gives us the 17. So that means the x value for this group is 4. Let's go ahead and find the x value for 12, 35, 37. So for, let's delete all this, 12, 35, 37. So 12, 35, 37. The 12 must come from this 2x because that's the only one that's divisible by 2. So that means my x value must be 6, right? Because 2 times 6 is 12. And you could see that's true for the other ones, right? 6 squared is 36, minus 1 is 35. And then 6 squared plus 1 is 37. So we know that this must have come from an x value of 6. Okay, part D. So here's some more Pythagorean triples. Describe this pattern, then see if you can think of another Pythagorean triple that doesn't follow this pattern. So one thing we can see here, notice that the middle length term and the largest term, they're only 2 apart from each other. So that's one thing we can describe here. The middle length side is 2 units less than the largest side. I guess instead of largest side, we could say hypotenuse. I don't think I spelled that right. Whatever. So we can see that here, but not every Pythagorean triple behaves this way, right? So what's an example of a Pythagorean triple that doesn't follow this x squared minus 1 blah, blah, blah pattern? Well, one example we can say is 5, 12, 13. So 5, 12, 13 is a Pythagorean triple. That does not follow the pattern. You could see that because notice the 12, it's not 2 smaller than the hypotenuse, it's actually only 1 smaller than the hypotenuse. We can see this because 12 is only 1 less than 13. Okay. All right, cool. Part E. The Pythagorean triple of 5, 12, 13 cannot be generated. We just talked about this by this group, okay, which has blah, 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 blah. Okay, so we're going to have a new pattern. So we saw the pattern we saw before where it had the x squared plus 1, the 2x, and the x squared minus 1, right? This one up here. But we can have a second pattern. Now, the second pattern that works is actually this x squared minus y squared plus 2xy equals x squared plus y squared squared. Okay, now you can show that this is true the same way we had done before. So what I would do is show that this squared plus this squared does in fact give me that squared. So I would do x squared minus y squared squared. So x squared minus y squared again. Multiply them together. When you multiply this out, it gives me x to the 4th minus x squared y squared minus another x squared y squared, and then plus y to the 4th. You could also combine, then you can combine this negative x squared y squared and negative x squared y squared. So that gives me x to the 4th minus 2x squared y squared plus y to the 4th. Now I'm going to do this 2xy squared. So that's 2xy times 2xy, which gives us 4, so plus 4x squared y squared. Then we're going to do this x squared plus y squared squared. X squared plus y squared squared. So that gives me the x squared plus y squared times itself. So times another x squared plus y squared, which gives us x to the 4th plus x squared y squared plus another x squared y squared plus a y to the fourth. And we can combine like terms here, x squared plus 2x squared y squared plus y to the fourth. And you see that matches the left side too, because you can go ahead and combine together this 4x squared y squared with this negative 2x squared y squared, which gives us x to the fourth plus 2x squared y squared plus a y to the fourth. And you can see it matches this right side. So because the sides match, we know that this holds true for the Pythagorean triple. So what does that mean for us? Well, that means we can find new Pythagorean triples. Okay, so what we can do, I'm going to go ahead and grab this formula, and we're going to use in part F, we're going to use the x value of 4, y value of 3. So x equals 4. Well, that's supposed to be a 4. X equals 4, y equals 3. And then we're just going to replace x and y with 4 and 3. So that's going to be 4 squared minus 3 squared. Then we have a 2 times 4 times 3 for the next side length. And then for our hypotenuse will be 4 squared plus 3 squared. So these will be our 3 side lengths of the right triangle. So 4 squared, that's 16, minus 3 squared, that's 9. 16 minus 9 is 7. 2 times 4 times 3, so that's 2 times 4, that's 8. 8 times 3 is 24. And the hypotenuse in this case is 16 plus 9, which is 25. So this does produce a Pythagorean triple here. 7, 24, 25. So we would write in here, a Pythagorean triple would be 7, 24, 25. Okay. I want you to use this x value of 7 and the y value of 5 to find this Pythagorean triple right down here. Okay. Now, what about for this 5 where you don't know the y value, but we do know this 9, 40, 41? Well, let's try it out. So our x value is 5, but we don't know the y value. But we know our 3 side lengths are, what were our 3 side lengths? 9, 40, 41. Okay, 9, 40, 41. 9, 40, and 41. So we know our x value is 5, but what's the y value here? Well, one thing I noticed is that this 2xy is probably going to be our 40 here. 2xy is probably going to be our 40. So 2x, x is 5, y we don't know, and this is going to be our 40. Solving for y, we can see 2 times 5 is 10, so we got 10y equals 40. Divide both sides by 10 to give us that y is 4. 5 and 4, that should work. Let's make sure it works for the other side lengths as well. 5 squared, that's 25, minus 16, yeah, that gives us the 9. And then 25 plus 16, right? 5 squared plus 4 squared, 25 plus 16 gives us the 41. So if our x value is 5, the y value would be 4 in order to create this Pythagorean triple. Let's do this last group as well. So here they give us the y value of 3, and then we have 27, 36, 45. (27, 36, 45). And they gave us that the y value is 3. Okay, So here we don't know the x value, but we know the y value is 3. Well, once again, I would use this middle length to help us out. We know this is going to be 2 times x times y, and our y is 3 in this case. And I want to know what is the x value that gives us 36. So 2 times 6 is 6, or sorry, 2 times 3 is 6. So we have 6x equals 36. Dividing both sides by 6 gives us that x equals 6. And you can see it's going to work for these other side lengths as well. Notice 36 minus 9, because y squared, 3 squared, is 9. That gives us the 27. Similarly, 36 plus 9 gives us the 45. So we know that if the y value is 3, the x value is 6, will give us these 3 side lengths. Okay. And I allowed you to do that one on your own. You could look at the example of the 4-3 example here. Okay. Well, that's it. I hope that all made sense. I hope you're able to get through it. And again, if you'd like to say thank you, like, comment, subscribe, you know the deal. But most of all, if you could share this with someone else who would find this useful, that's the best way you can thank me. All right. Well, with that, take care, and I'll see you guys next time.